Hi, this is Jason McIntosh. In this quick video, I'm going to show you how to compute and plot the impedance for an acoustical membrane. So I'm going to create a modeler module. We're going to go to the acoustical menu and select acoustical membrane. We're going to want to put a zero pressure on the other side because we're going to plot the impedance of just this membrane. I'm going to create a pressure source to drive it. Now we can go ahead and solve this system. I'm going to go to miscellaneous and create a graph element. We're going to connect it up to the left node here of the membrane element. And when this graph element was created, this graph window was also created. It's kind of hiding in the background. By default, it's plotting pressure. I'm going to select impedance instead. And to get the real and imaginary parts of the impedance, I'm going to click on Advanced Options, check Real and Imaginary, hit OK. And now it creates a second graph in there, which shows the real and imaginary part of the impedance, as well as the magnitude. To make these lines a little thicker, I'm going to go to Set Line Buffer and make the weight 3. Hit OK, and now it's a little thicker, so you can see the impedance of this membrane. Now these are the default values of the membrane, which is just using mechanical mass compliance resistance parameters. You can select calculate mass compliance from plate equations by selecting this radio button. And now mass compliance is grayed out, and you have to enter the material's thickness, density, Young's modulus, and Poisson's ratio. In the units shown here, you can select different units if you know the material's properties in different units. And then from these, you can calculate, it'll calculate the mass compliance, or the mass compliance of the membrane, and compute a new impedance for you. So this is how you can use Aries to compute the impedance into one of these membranes. You can also look at the net displacement by selecting instead of impedance, you can select displacement. Now when you go over here, you're seeing the displacement in RMS millimeters. It's very high around its resonance, but for the most part it's relatively low. If you right click, select zoom, you can kind of zoom in here and take a look at what's going on. Again, it's quite small at the higher frequencies. So this is its displacement under an excitation of 94 dB SPL. If you want to see what that is in pascals, you can just select pascals. That's about 1 pascal. Now this is the mean average displacement of the diaphragm. It's been averaged over the surface area. And it's also its RMS level. If you want to see what the peak average level is, you can go to Advanced Options. Now select peak level, hit OK, and now it'll show you the peak to base level of the motion. It has a lot of motion at resonance because there's no damping. If we come in here, add some resistive damping to this, I don't know what to pick. I'm just going to say 50 ohms. See if that did anything. Yeah, it completely destroyed the resonant behavior. Let's go with just 1 mechanical ohm. And it's still destroyed. So if we drop the resistance down to 0.0001 mechanical ohms, we get we still get a bit of a resonance, but it's heavily damped. We can add 1 more 0 there to make it even smaller. And now you're seeing the resonance, but it's at least a little bit damp. Let's go for like 3, 4 zeros. Oh, we got a 3, 4 zeros and a 3. And now this is looking like a still pretty good resonance, but it's damped. And again, we're looking at displacement here. If we want to see impedance, we got to go back and select impedance again. Uh, so yeah, it dampened the impedance, dampened the impedance at that resonance. So that's pretty much it. This is just a quick demo showing how to calculate the impedance of a membrane using these properties. Actually, this is impedance of a plate. We could have used impedance of a membrane by selecting this third checkbox. Same type of procedure. Thank you. Hope this was helpful.